Hello everyone and welcome. In this video I'm going to show you how to do a one-way independent measures ANOVA in SPSS. So in this case I'm using version 25, but this should work for pretty much any version of SPSS that you're working with. So I'm working with activity 8.1 in our textbook, where we have a design where we have three different groups who are in these groups based on how much sleep they're assigned to get each night. So we have three groups that are randomly assigned to receive either 6, 7, or 8 hours of sleep each night. And then we're looking at how much time in minutes they spend on social media. So we want to know does sleep deprivation have an effect on or particularly increase the amount of time people spend on social media? So to test this, I'm going to do a one-way ANOVA by clicking on Analyze, and then I will click on General Linear Model Univariate. Okay. My dependent variable is the amount of time people spend on social media, so it's SM time that I'll move into my dependent variable box. And then sleep group is my fixed factor. Factor is another word for independent variable, so I'm moving my independent variable over into that box. Okay, so next we click on Options. Under Options, ask for descriptive statistics, and we also want estimates of effect size there. Right, once you've clicked on descriptive statistics and estimates of effect size, you can just say Continue. Under Post Hoc Test, we're going to need to move our factor into the Post Hoc Test For box. We're going to ask for sleep group. It was our groups. And we want the LSD test. The equal variances assume LSD test there is the Fisher test. And then say Continue. Okay, after you've done all of that, you can click on OK. And that will give you your output for the univariate ANOVA. Okay, so you can see here that we have means and standard deviations for our three groups. We have the number of minutes of social media group or use for the 6-hour, 7-hour, and 8-hour sleep group. And we also have standard deviations for those three groups. You can see that our standard deviations are very similar across these three groups. There are no concerns about homogeneity of variance violations. Now we can go down and look here at the test of between subjects effects. This is our overall ANOVA summary table. And there's a lot of information here that we're not going to report. We're looking at the two sets of degrees of freedom here are the sleep group degrees of freedom. This is the between treatments degrees of freedom, which is 2. And then we have the error residual or within treatment degrees of freedom, which is 177. So our F is the 5.847. It's the one in the same row as our independent variable, which is sleep group. And it has 2 and 177 degrees of freedom. The p-value for that is 0.003, which tells us that the data are not consistent with the null. Our null hypothesis is that all three means are equal to each other, and then this is showing us, well, they're not. At least one of them is different from the others. We need to look at post hoc tests to figure out which ones are different. You'll note that you also have partial eta squared here. So SPSS only gives partial eta squared as a measure of effect size. If you want omega squared, you need to either do it by hand or use an online calculator. Okay. All right, so our p-value of 0.003 shows us that, yeah, all three means aren't different from, are not the same as each other. So now we need to look at our post hoc test to see where the differences may lie. So with our post hoc test here, we did the Fisher post hoc test. And we're comparing the 6, 7, and 8-hour sleep groups. Okay, so our first row of this output is looking at groups 6 and 7. When you compare those two groups, the difference between those means is 29.92 with a p of 0.023. That shows us that that difference between these two groups is probably not due to sampling error. The data are not consistent with the null hypothesis. And if we go back and look at our means, we can see that group 6 used social media more than group 7, right? That sleep deprivation was associated with or led to more social media use in that group. We also have a confidence interval around that mean difference. The 95% confidence interval is between 4.15 and 55.70. So I'm 95% sure that the true mean difference is between those two values. Our next row is comparing group 6 to 8. Here the mean difference is 43.68 with a p of 0.001. So the difference between group 6 and 8 also seems to be unlikely to be due to sampling error. If I go back up here, I can see that, again, group 6 seems to be using social media quite a bit more than group 8. The actual mean difference we observed was 43.68, and I'm 95% sure that the true mean difference is somewhere between 17.9 and 69.5. Okay. So that's 2 of our post hocs. We're comparing group 6 to 7 and group 6 to 8. Now we also need to look at now group 7 and 8. But you'll note that the next one here in the output is group 7 to 6, which is, we already did group 6 and 7. This mean difference of negative 29.92 is the same one as that was up here. So we're jumping down to compare group 7 to group 8, which is the last one. Here our mean difference is 13.76, and our p-value is 0.294. Which tells us that group 7 and 8, there really isn't a difference there. The difference we're observing is likely to be due to sampling error. And the true mean difference in the population is probably somewhere between negative 12.02 and 39.54. I'm 95% sure that that is the case. Now these last 2 rows in this table are not rows that you need. They're redundant with the previous rows. The comparison between 8 and 6 is the same as it was between 6 and 8 up here. The 43s and 43 are the same comparison. And then comparing group 8 to 7 is the same as comparing group 7 to 8 up here. So there's like double the information that you need in this table. So like half of it you're not going to be using there for your post hoc tests. Okay, so in SPSS, you get these mean differences in raw score units. You don't get them as standardized effect sizes. So if you need standardized effect sizes, you need to use a different program to get standardized effect sizes and confidence intervals around them. Same thing if you need omega squared as a measure of effect size. You either need to compute that by hand or use another program or an online calculator. All right, finally, I'll just show you how to get graphs real quick. If you click on Analyze, we can go to Descriptive Statistics and Explore. And, sorry, I already did this, so let me move the variables back over here. Sleep group is our factor. It's our independent variable, so I put it in the factor list. And my dependent variable, I put in the dependent list, which is social media time. Under plots, I'm going to ask for the histogram. I don't need the stem and leaf necessarily, but you're welcome to get it if you want it. And I'll just click on Continue. And then I get a bunch of descriptive statistics, histograms for each group, as well as box plots for each group there to help you interpret and look at your data. All right, and that is all you need to run your analyses for SPSS. But again, if you need those effect sizes, you'll need to use a different program there as well. All right, well, that is all, and I hope that helps. Good luck.